My name is Night Teeter, and today I'll be teaching you a conic section from expanded equation, specifically for an ellipse. So we're going to start with the equation we have in front of us right here. 25y squared minus 108x plus 100y plus 9x squared plus 199 equals 0. So right now it just kind of looks like a mess. I want to group my variables together. So I'm gonna start with my x because that's how I like to do it. So 9x squared minus 108x plus 25y squared plus 100y plus 199. That's all equal to 0. Now, I would like to group my variables together because I don't want my x squared and my y squared to have a coefficient. I want them to be standalone, so I would like to factor out the common multiples in my specific variables. And so the way to do that is with the x, I'm going to do 9 times x squared, because 9 times x squared is 9x squared, minus 12x, because 9 times negative 12 is negative 108, so that's how you factor out your common multiples. And then we'll do the same thing with the y's. So we have 25y squared, so it's going to be 25 times y squared, and then our 100 divided by y is going, or our 100 divided by 25 is going to be positive 4y. We know that's true because 4 times 25 is 100, 100y is 100y, and we add back our constant. It's all equal to 0. Now, what do we do next? Well, next we need to complete the square. There we go. Couldn't think of it for a second. We need to complete the square for each of our variables, for our x equation and our y equation. So we're going to rewrite that 9. Then we're going to do x squared minus 12x. And then we're going to put something there. I'll come back to it in a second. I'm going to rewrite this over here. Y squared plus 4y plus 199 equals 0. Okay, now we're going to go back. Oh shoot, I forgot to skip a spot with the y. So leave some room over here for y. Plus 199 equals 0. Okay, now let's go back to those spots that I left. So if you don't know how to complete a square, the way you do that is to take the b in your equation, because x squared minus 12x is a quadratic, or is a quadratic equation, right? So what you do is you take b and divide it by 2. Your coefficient in front of x squared is a, in front of x is b, and your constant is c, but currently we don't have a constant, but we're about to add one right now. So you take b divided by 2, negative 12 divided by 2 is negative 6, and you square that. So negative 6 squared is 36, so we will add 36, right? And whatever you do to this left side over here, you have to do to the right side. So over here, we added 36. So we have to add 36 over here, right? Well, actually, we added 9 times 36 because this 36 is in parentheses. So we really added 9 times 36. And 9 times 36, here, let me move over here to add it, is plus 324, right? Because that's what 9 times 36 is. Oops, did not mean to do that. Let me zoom out a little bit so we can see that a little better. Oh, shoot, didn't mean to show you that over there. So now we have plus 324. Now we also have to do the same thing with y right here. So our b value in y is this 4 right here because it's in front of the y variable. 4 divided by 2 is 2. And so we have to square that 2. So squaring 2 gives you 4. That's a pretty bad 4. Gives you 4. There we go. It's a little better. And so now we add 4 to both sides, right? Because we added 4 over here. So now we add 4 over here. Well, no, because again, we added 25 times 4 because it is in this parentheses. So really, we're adding another 100, right? Oops, cut off. Another 100. So if we're doing that, now this is a perfect square. And here I'll show you in a second. This becomes x minus 6 squared, right? And we'll go through it together. X times x, that's x squared. X times negative 6 minus negative 6x. Negative 6 times x, negative 6x. Negative 6x minus 6x is negative 12x. And negative 6 times negative 6, positive 36. So this is the same thing as this, right? So we just rewrote it. This is a perfect square. These are the same things. Now we're going to do the same thing with y, except I'm not going to explain it because I just did. With the x's, just know that this becomes y plus 2 squared. And then we have our constant still. And then now let's add up what we have over here. 324 plus 100 is 424. And we have a number over here. We've had this constant here the whole time. Let's just move this over now. So let's rewrite the whole thing. 9 times x minus 6 squared plus 25 times y plus 2 squared is equal to 424 minus 199. And that should give you 225. And so this, now we have an equation. We have our x's and y squared, how they should be. However, if you remember, when you have conic sections, you need your variables to be equal to 1. So the left side has all your variables and all that fun stuff. Your right side needs to be equal to 1. So how do we make this right side equal to 1? We divide it by 225. If we divide the right by 225, we divide the left by 225. So this is going to turn into x minus 6 squared over 25. Now the way I know that is because 9 divided by 25, 9 over 25, simplifies down to 1 over 25. So you can just imagine a 1 right here as our coefficient, but because it's a 1 and you're multiplying, you never write that 1. So there's an imaginary 1 right here over 25 plus, now we'll do the same thing with our y plus 2 squared over 25 over 225 should give you 9. And then we keep our constant 225. So now, oh shoot, nope, that's not still 225 because we divided by 225. That is now 1. Boom. Okay, so now we have our equation right here. This is our equation of the ellipse. This right here. Let me get a little circle for you. This right here is the equation of our ellipse. Now, that's just the first part, because now we have to graph this thing. So, first thing you need to know for graphing, where's your center going to be at, right? Graphing an ellipse, you need to know where the center is. Okay, so our center is going to be at 6, comma, -2. Okay, so our center is at 6, comma, -2, right? And so that's where our ellipse is going to start. Now, I think I should try grabbing all this and move. Oh, it didn't grab. Okay, what the heck? I shouldn't have tried doing that because now I messed my thing up. Okay, I'm going to bring this back 6, comma, -2. Okay, that's our center. And I'm not going to try moving this anymore because that didn't work. And now, as I accidentally showed you earlier, I already have a graph pre-drawn because that's just going to save a whole bunch of time. So now we're going to go graph up here. So remember 6, comma, -2. 6, comma, -2. I'll zoom in here, make it a little easier to see. Get this out of here. 6, comma, -2 is going to be our center. So that's right here, and that's right on top of this 6. So I'm going to erase this 6 real quick. Just know that this right here, this line is our 6. I'm going to erase this, and now I will plot our point. Here's 2 along this line, and that's 1, 2, 3, 4, 5, 6 right there. Okay, so there, here, I'll make that a little bigger. There is our 6, comma, -2. That is our center, right? But now, how do we know where else to put points? Well, if we look back at our denominators over here, our denominators are 25 and 9, right? And so that's very useful because that tells us about our axes. So our x-axis is going to have a distance of 5 away from the center. And the way I know that is because to find the distance away from the center, you take the square root of the denominator. So the square root of 25 is 5. So I know that each point on the vertices, the 2 vertex points, are going to be 5 units away from the center. And the same way with y, I know that they're going to be 3 units away from the center. So we'll start with our x. We're going 5 units away, right? So we get back up here. And to make it easier on myself, I already have the points that I need to go to marked out. That's why I had the 6. So right here is the 11. And again, I'm going to erase it. But no, right here is 11. And we were at 6, right? 6 plus 5 is 11, right? Because that's the distance away. We went 5 units to the right, so we went to 11. And we stay on that same y coordinate, same y plane. And so we put our point right there, and that is one vertex. And then we do the same thing going in the opposite direction. Now, 5 to the left of 6, 6 minus 5 is going to be 1. So we put our other vertex at the point 1, comma, -2, right? And so now we have our 3 x coordinates, the 3 important, we have the 3 important points on the x axis in terms of the both the vertices and the center. Now we need to do the same thing with y, and as I said earlier, we're going to be moving 3 units. And the way I know that is because our denominator here is 9, and the square root of 9 is 3, so there will be a distance of 3 away from the center in the y plane. So for these, we stay on the same x line of x equals 6, right? And we go down 1, down 2, down 3, right here to -5, because -2 minus 3 is -5. And then we do the same thing going up. So we have -2 plus 3 is going to give us 1. So we're at 6, comma 1 here. And now we have all of our points needed for an ellipse. Now all that's left to do is to draw said ellipse. And I probably should have practiced this a little bit beforehand, but I believe if I go right here and then I bring it up and over to there, and then I make this, how do I make this clear? There we go. I make it clear. You can see I got it a little off, but here, let me move it down a little bit. There we go. Now I go through all of our points and I have our center here. So this is how you draw the equation that we just solved for. So this equation up here that we initially had, that we solved for, solved all the way down to here and got an equation for a conic section, and we knew it would be an ellipse because we had an x squared value plus a y squared value, and our two denominators were not equal. So that's how you know that you had an ellipse. If the denominators were equal, it'd be a circle most likely. If there was a negative x or y value and a positive x or y value together, then like one positive, one negative, you know you would have a hyperbola. And if one x is squared, if one of x or y is squared and one of x or y is not squared, then you know you have a parabola. But we solved for our ellipse here with a positive value for both, and then we knew how to find the center, and then from there we also knew how to find the distance away each vertex would be, and so we knew how to graph up here. We took it over, we plotted it on a graph, and we were able to successfully draw an ellipse. Thank you for watching.